All right, let's talk a little bit more about, standardizing data, converting it into a unitless scale. So the goal is to bring values of any random variable to have a common scale without distorting the differences in the range of the values. So let's go back to, I kind of want to say, let's go back to a simpler time. Um, let's go back to section 2.7. And this is where we first talked about z-scores and converting from any data scale to a z-score scale. And so we can take data from one scale and convert it into a z-score using the formulas that I just showed you just recently. And I gave some examples here. This was being presented with a box of donuts and how many donuts people ate out of the box. If you remember from this example, is that when we took uh, our data, which was in a donuts scale, so um, eating one donut, or eating two donuts, or three donuts, four donuts, or five donuts. So when we converted our data from a donut scale, and we converted each of these data points, each of these datums into a z-score, notice how the shape of the data did not change, right? We still had this kind of pyramid-shaped data here, and we had this pyramid-shaped data there. And notice that the average number of donuts that were taken out of a box was 3. And that is at the center of this distribution of datums. And when we look at the center of the distribution here under this z-scale, the center is at 0. So you remember when I talked about the mean of a unit scale when converted to a z-score will be 0. But the shape of the data isn't distorted, it's not changed. The shape stays the same. So now if we come back over here to chapter 6 and standardizing data, this is where I say we're bringing the values of a random variable to have a common scale without distorting differences in the ranges of the values. Standardizing data allows one to compare scores between different types of variables. And kind of how that gets done, algebraically is this was the equation for the normal distribution. Okay, that gave us this shape here initially. And you can see it's got mu and sigma there in the equation. And it produces this shape here. And this is where we have, values of x with any unit you can imagine. But when we convert a normal distribution to a standard one, that's when we convert those values into a z-score. And if we take x minus mu sigma and we substitute a z in here, that's where this z comes from, right there. And when we do the conversion, the shape stays the same. We've just changed, apologize for that. We've just changed the unitless scores here across the horizontal axis. So I think that's about as much as we need to discuss or explain. Let's get into some examples and see if we can see how we apply these ideas. Okay, here we go.